Hello guys, let us see what happens when two SHMs meet or two oscillations, two motions they combine. Okay, let's have one of them as x1 is equal to a1 sine omega t plus alpha 1, and the second one is x2, and that is a2 sine omega t plus alpha 2. Okay, now here right in the beginning I'm going to make one change here. I don't want this small a's involved over here. Okay, so I'll make them capital A's, A1 and A2. Okay, big is better. Now the resultant SHM, okay, resultant displacement. Resultant displacement would be vector sum of these. So x is going to be equal to x1 plus x2. I would say x bar is equal to x1 bar plus x2 bar. Okay. Now, what about the individual SHMs? You can see that omega in both the cases is same. Angular frequency is same. That means the time period of both the SHMs, it is same. Okay. They are traveling along the same straight line. Okay. Now let us see what happens to the resultant. Okay. Now I'm going to have a very simple simple derivation of this. Okay, there can be even simpler derivation for than what I'm going to do here. Okay, but then after some time, after I'm finished with this, I'll explain the other type. Okay, I'm going to do it in a very simple manner. I'm going to expand this and I'm going to expand this. Okay, so my x is equal to a1 sine omega t cos alpha 1 plus cos omega t sine alpha 1 plus a2 sine omega t cos alpha 2 plus cos omega t sine alpha 2. I have purposely written them one below the other. Okay, so that I should be able to take sine omega t common here and cos omega t common here. Correct. So then that makes it sine omega t, okay, into a1 cos alpha 1. Correct. I'm going to take sine omega t common between these two. Okay. Plus cos a2 cos alpha 2, a2 cos alpha 2 plus cos omega t, and then these I'll take outside. So a1 sine alpha 1 plus a2 sine alpha 2. Now you would say what did I achieve by doing this? Okay, but now this is, see, amplitude a1, is it not constant? Amplitude a2 is constant. My alpha 1 and alpha 2, which are initial phases of oscillation, they are also constant. Are they going to change? No. Same is the case over here. Alpha 1, alpha 2, a1 and a2 are constant, so I'm going to assign some value to these two. Okay, one is a pair of cosines and the other is pair of sines. Okay, so this first one, okay, I'm going to write here as r cos delta. R cos delta is equal to a1 cos alpha 1 plus a2 cos alpha 2, and r sin delta is equal to a1 sin alpha 1 plus a2 sin alpha 2. Correct. So I am going to be able to write this as equal to sin omega t. Now r I am going to take common here. Sin omega t cos delta plus cos omega t sine delta, and then this whole thing is going to be equal to, I'm going to have x is equal to r sine omega t plus delta. Okay, this expression, if you see this expression, you will be able to notice here that r, capital R, is the resultant amplitude, and delta is the initial phase of my resultant SHM. Okay, I had two SHMs. One is given by x1 is equal to a1 sine omega t plus alpha 1. The second one is a2 sine omega t plus alpha 2, and my resultant is given by x is equal to r sine omega t plus delta. Now the question is what is this r? What is the magnitude of r? But then what we have done here is we have substituted r cos delta is equal to so much and r sine delta is equal to so much. Is there any way to figure out or calculate what is your r? Yes, it is there, and for that what I'm going to do is I will square and add these two equations. So whatever I have substituted, I'll square both the sides and add. So then r square cos square delta plus r square sine square delta. Okay, now r square cos square delta plus r square sine square delta, I am going to be able to take r square common, and in the bracket what will remain? It will be cos square delta plus sine square delta. But then what is cos square theta plus sine square theta? Is it not equal to 1? Correct? So my r square is equal to square of this right hand side plus square of this side. Correct? So it is going to be, now instead of writing it over there and doing it further, I'm going to directly do it. Okay, you will get the detailed notes in the description. Okay, and so it is going to be equal to a1 square cos square alpha 1 plus a2 square cos square alpha 2 plus 2a1 a2 cos alpha 1 cos alpha 2 very less space is there, but then purposely I am doing that. Okay, I want to finish that in this line. Okay, just bear with me, you will get the proper notes in the description, right? So this second one, so it is going to be a1 square sine square alpha 1 plus a2 square sine square alpha 2 plus 2a1 a2 sine alpha 1 sine alpha 2. Correct? And we are going to add them, right? Okay, now here if you see this a1 square and a1 square, you can take common. Cos square alpha 1 plus sine square alpha 1 is equal to 1. Correct? So this will become a1 square plus a2 square and a2 square. You can take common here, and what you get there in the bracket, cos square alpha 2 plus sine square alpha 2, which is equal to again 1. Right? So you have a2 square here plus 2a1 a2, you can take common, 2a1 a2, and what remains? What remains is cos alpha 1 cos alpha 2 plus sine alpha 1 sine alpha 2. Is it not cos of alpha 1 minus alpha 2? Right? It is cos of alpha 1 minus alpha 2. Okay? If you have any doubts about this, refer to the trigonometry video on this channel. Okay? And then that makes my r square is equal to so much. Correct? So my r is equal to a1 square plus a2 square plus 2a1 a2 cos of alpha 1 minus alpha 2 and the whole under root sign. Right? Now what? I have got the magnitude of resultant. Okay, magnitude of amplitude of resultant SHM. So I'm quite fine with that. Okay, but then see, displacement is a vector quantity. You need to have uh, uh, direction of that, correct? The expression over here, if you look at the expression, is it not something similar to what we did in parallelogram law of vector addition? The expression is similar to that, okay? But now my point is, I had said that my resultant displacement is x. It is given by x is equal to r sine omega t plus delta. Okay, let us figure out delta. What is delta? I must know the initial phase of the resultant SHM, correct? So what I do is I just take the ratio of that if I divide this expression by that expression. Okay, so that r will get anyway cancelled, and what you get there is tan of delta. So tan delta is equal to a1 sine alpha 1 plus a2 sine alpha 2 upon a1 cos alpha 1 plus a2 cos alpha 2. Okay, so that is the initial phase of the resultant. So I think it may be fine up to this. Now in the beginning of this video I had said there are two ways of doing it, and one I have done here, okay, which is little lengthy, okay, but still it is straightforward. That is what I feel. I don't know what you feel, but then I can tell you one simpler way of derivation. Okay, I have mentioned here that it looks like parallelogram law of vector addition. Okay, so for that maybe we can proceed like this. I'll just make the sketch here. Okay, this is my my displacement or SHM1, and if I take, now since there is difference in the initial phases, okay, so this is x1 and this is x2, correct? Initial phase of this is alpha 1 and initial phase of that one is alpha 2. So what is the angle between them? Is it not alpha 1 minus alpha 2, correct? And then what is the magnitude, amplitude, maximum value of displacement here? It is a1 here and a2 here, correct? So my resultant will be somewhere here. I complete the parallelogram here and here, and I get the resultant here, r, correct? So my r is equal to a1 square plus a2 square plus 2a1 a2 cos of alpha 1 minus alpha 2, and whole thing under square root, correct? So that's it. But then what about this angle, correct? For finding that angle you would need more work over there. So I followed this, a lengthy method, but then it is quite easy to understand. Okay, in the next video we are going to talk about special cases. Here we'll take the resultant, the magnitude of resultant, and then discuss a few special cases of these SHMs. Thank you so much.